Good morning all. I Dr. Sarika Panwar welcome you all in the video lectures of machine learning. Today's topic of discussion is artificial neural network. It is unit number 4 of machine learning elective 3 subject of electronics and telecommunication engineering in Savitribai Phule, Pune University. Artificial neural network, in short, it is called as ANS. What is the history of ANS? That we will first see. History of artificial neural networks stem from the 1940s, the decade of first electronic computer. We know that 1940s is the decade of first electronic computers, and that time only Warren McCullough and Walter Pates created a computational model for neural networks based on algorithms called threshold logic. After that, in 1957, the first important step took place when Rosenblatt introduced the first concrete neural model, that is the perceptron. We know that the beginning of artificial neural network starts with the invention of perceptron. Since the invention of backpropagation algorithm, research in artificial neural network has remained active. It leads to many new network types as well as hybrid algorithms and hardware for neural information processing. What is artificial neural network? Artificial neural network is the network of neurons, and neurons are analogous to the neuron in our human in the human brain. So artificial neural network, it consists of the pool of simple processing units which communicate by sending signals to each other over a large number of weighted connections. In artificial neural network, large number of neurons are interconnected together. N is an information processing paradigm. Artificial neural network are devised basically for processing the information, and it is inspired by the way of biological nervous system. It is configured for specific applications like pattern recognition and data classification. So a set of major aspects of parallel distributed model include, the artificial neural networks are nothing but the distributed computing system, parallel distributed model. So what is the major aspect of parallel distributed model? It includes a set of processing units. There is no centralized processing unit like in CPU, but it is a set of parallel distributed units which is there in the artificial neural network, and there a state of activation for every unit is there, which is equivalent to the output of the unit. There are the connections between the units. Generally, each connection is defined by the weight. A propagation rule which determines the effective unit of a effective input of a unit from its external input. An activation function which determines the new level of activation based on the effective input and current activation. There is an external input for each unit, and there is a method for information gathering that we call the learning rule, and there is an environment within which the system must operate, providing input signals, and if necessary error signals are there. So that is the set of the major aspects which are required for the parallel distributed model, and that everything is there in the artificial neural network. We know that in our computers there is a centralized processing unit, whereas in neural network there is highly parallel processing units which are available. So that is the basic difference between the standard computers and neural networks. So standard computers are centralized processing units, and neural networks are highly parallel processing units. This central processing unit which is available in standard computer is fast processing unit, and individual neurons which are nothing but the parallel processing units in neural networks are the slow processing unit. In computers, the central processing unit is reliable, whereas in neural networks, a single neuron which act as a parallel processing unit is unreliable unit. There is static infrastructure in CPU, whereas in neural network it is dynamic infrastructure. That is the basic difference between the standard computers, wherein a single centralized CPU is available, which does all the processing tasks sequentially, and in neural networks there are large number of neurons available which does the processing parallelly. That is the basic difference between the standard computers and neural network. So there are two basic reasons why we are interested in building the artificial neural network. First is technical viewpoint and second is biological viewpoint. So as far as technical viewpoint is concerned, some problems like character recognition or the prediction of the future states of the system require massively parallel and adaptive processing like the human brain. We know that by using the machine learning, we go for the future predictions, and for such future prediction, adaptive processing and massively parallel processing is required. As far as biological viewpoint is concerned, artificial neural networks can be used to replicate and simulate the components of the human brain or animal brain, thereby giving us insight into the natural information processing. How our brain does the calculation, similarly the artificial neural network also does the processing and calculation part. That is why we are interested in building the artificial neural networks. The building blocks of neural networks are the neurons. We know that neural networks are nothing but the array of neurons. So these neurons are the building blocks of neural network. In technical systems, we also refer them as a unit or nodes. Neurons we can also call as units or nodes. Basically, each neuron receives the input from many other neurons, changes its internal states by using the activation function, and that is based on the current input, and it sends one output signal to many other neurons, possibly including its input neurons. In artificial neural network, the information is transmitted as a series of electric impulses, and that impulses are also called as spikes. The frequency and phase of these spikes encodes the information. In biological systems, we know that one neuron can be connected to as many as 10,000 other neurons in our human brain or biological system. Usually, these neurons receives its information from other neurons in a confined area, and that area is called as the receptive field. How the artificial neural network works? In artificial neural network, there is either a hardware, it can be either a hardware implementation or a computer program which strives to simulate the information processing capabilities of its biological exemplars. So in artificial neural network, we simulate the information processing capabilities of its biological exemplars, and artificial neural networks are typically composed of a great number of interconnected artificial neurons, and artificial neurons are simplified models of their biological counterparts, and is a technique for solving problems by constructing software that works like our brain. So this is a simple architecture of artificial neural network. Here we can observe that these neurons are arranged in various layers. In this diagram we can observe that there are three layers: input layer, hidden layer, and hidden layer 1 and 2. These two hidden layers are there, and output layers. So including these two hidden layers, we have 4 layers in this simple neuron model. These neurons, which behaves like our biological human brain neurons, these neurons are present in each layer, and these are connected with the other neurons in other layers. By using these connections between these neurons, the information is carried basically these neurons, takes the input in the input layer, it add all the input signals, and then that added signals, that summed up signals with weighted output is given to as an input to this other layer neuron. So large number of neurons are connected with each other, and this every connection is a weighted connection. Why we call this as a weighted connection? Because weight is associated with each and every connection. As far as characteristics of artificial neural networks are concerned, it is neurally implemented mathematical model. So artificial neural networks are nothing but the mathematical model which is implemented based on the neuron operation. Huge number of interconnected processing elements called neurons are there for processing, and input signal arrive at processing element through connections and connected weights. Before going into the architecture of artificial neural network, we first need to revise the human brain architecture. Human brain is a massively parallel information processing system. Our brain are a huge network of processing elements, and a typical brain contains a network of around 10 billion neurons. This is a neuron structure. Here we can observe that this is the nucleus of the neuron, and around this nucleus there is a cell body, and surrounding to this cell body there are dendrites. This cell body in all is called as a soma, and there is an axon which transmits the information processed by this nucleus. So actually such billions of neurons are interconnected in our brain, and axon is actually the neurotransmitter. It transmits the impulse from one neuron to other neuron. Now how these neurons or cells are connected with each other? In this diagram we can observe that this axon is carrying the impulse, electric impulse from some other neurons. There may be some other neurons here. So this axon is carrying the electric impulse from this neuron towards through the axon towards the dendrites of this neuron. Dendrite will collect the electric impulse from other neurons, and such all input impulses will be collected through all these dendrites, and that will be added by this nucleus. Okay, so this neuron will add all the impulses, dendrites, which is coming from some other neuron. Then that added signal will be processed, and then it will be transferred to some other neurons through this axon. Synapse is nothing but a point where this axon just touches this dendrites, other cell body. So connections, we can say that all the connections from axon of other neuron to the dendrites of this neuron is done by using this synapse. What are the dendrites then? Dendrites are the input. Why we call dendrites are the input? Because they are taking the inputs from some other axon. Like we can observe here in this diagram that this axon is carrying the information from some other neuron. So here we can see that how it is carrying the information, and it just touches the dendrite of this cell, and it collects and this dendrite will collect this information into this neuron. What is cell body? Cell body is a processor. Why? Because it will collect all the inputs from other neurons, and it will add it up, and then it will be processed. So this cell body we can call as a processor. What is synaptic? Synaptic, this synapse, single synapse is shown here. So it is just the link between the other neuron and this neuron. Synaptic provides a link between some other neuron and this neuron, and axon is a link actually which carries the electric impulse from this neuron to some other neuron. So, here in this diagram we can observe that how this output given by this axon, given by this cell is transferred to some other synapses. Synapses is just a link for other neurons. So, with this with these two synapses, we can say that the information carried by this axon will be transferred to some other neuron. So, this is how human brain works. So, neuron is connected to other neurons through about 10,000 synapses. So, this single neuron is connected to almost 10,000 other neurons. So, 10,000 synapses are there. A neuron receives the input from other neurons, inputs are combined, and once input exceeds a critical level, the neuron will discharge a spike, that is an electrical pulse down the axon to the next neuron. Okay? So, this is how our human brain works. This axon ending almost touch the dendrites or cell body of the next neuron. Transmission of an electrical signal from one neuron to the next is affected by the neurotransmitter. We will compare this biological neuron with artificial neural network. We have seen that how these dendrites, these are the dendrites which collects the information. So, dendrites acts as an input to this cell body wherein there is a nucleus. So, the information will be collected, taken as an input to this cell body, then it will collect the information, it will sum up that information, and then that will be processed, and then that processed information is converted into an electric impulse, and that electric impulse will be carried by the axon to some other neurons. This is how the biological neuron work, and now we will understand how our artificial neuron work. Now, in artificial neural network, these are the inputs, x1, x2, xn, these are the inputs. Now, this input layers, inputs will be collected at the input layer of the neural network, and then those inputs will be multiplied with the weights. So, it will be x0, x0, w0. Similarly, here it will be x1, w1. So, all these weighted, now we can call this as a weight. These weighted inputs are now collected here in this processing element. So, this processing element is actually the neuron, artificial neuron. Okay. So, this artificial neuron will collect these all weighted inputs. It will add all these weighted inputs, and then it will process. And for processing, this activation function is playing a important role, because these all inputs will be added together by this neuron, and then activation function will be used to process that information, and then we will get the output. These are the input x1, x2, xm, then this processing will be done by the neuron, and it will give you the output. So, these are not only the inputs here, these are the weighted inputs. So, we can call this connections. These are the connections which makes the connection between the input and the neuron. These are the connections. So, these are not merely connections, these are the weighted connections, because it multiply the weight to the input. So, xm, wm, that will be the weighted input, x2, w2, weighted input 2, x1, w1, weighted input 1. These will be added together, and then output we can get. But not all the inputs are equal, and not all the weights are equal, that you have to remember. The transfer function play an important role. Once we add these all inputs, then it will be processed with the help of this activation function or transfer function, and we get the output. That is the architecture of simple neural network. Okay, thank you students. Rest of the part we will discuss in next video.